Okay. Long answer to your question. What are we doing today? Yes, we're doing section 5.2. Longer answer is we're going to also kind of quickly recap 5.1 as well. We didn't really do much of that the other day. Monday it was a recap of chapter 4 is what we were looking at. Ooh, hang on, Yinghua just joined us. Let me let Yinghua in here. Admit. There we go. All right, Yinghua, can you see me, hear me okay? Hello? You there, Yinghua? We'll keep going. He'll chime in. All right. So anyway, like I said, we're going to do kind of a quick recap of 5.1. We're then going to get into 5.2, where we're going to do more analysis of those polynomial functions, those cubic ones, those quartic ones, with more properties that go along with that. And then you should have, the other class had about 15, 20 minutes of class time at the end to be able to work on the assignment and try to get that done. And I'm guessing that'll be probably about the same. So that's the plan. 1 week from today is your final test of the year, or of the semester, I should say. Okay, so the reason I bring that up is if you need any help between now, especially on chapter 4. I know we haven't done a lot with chapter 5 yet, but especially on chapter 4, if you're still struggling on any of that stuff and you know you need some help, do not fake your way through this, okay, and say, well, let me just try to look like I know what I'm doing, or those types of things. Because when you get to the test, you're not going to be able to fake your way through it, okay? So if you need some help, either let me know and I can bring you in on Friday, okay? We can go over some things together and get you there. Or you can always just go straight out to Canvas and on my homepage and just sign yourself up for coming in on Friday, okay? So either one, but like I said, this is it. This is your last opportunity a week from today on that test. And like I told you the other day, there's a lot of people that are borderline grades, whether it's passing versus failing, whether it's a B versus a C, whatever, that kind of stuff. Okay. So what we are going to do today, let me get into that. I printed out the notes for you again. So let me give you that. I won't always do that, but I had these already printed and I changed a little bit. Oh my. All shoes are so bad at it. I doubt it. Because at least you wash your hands. You never wash your shoes. Well, you should at least wash your hands. All right. Let's take a look. Don't ignore the box at the top, the warm-up box. We had already done that. That was the warm-up from lesson 5.1. I had moved that. So you can ignore that part of it. That was just a chapter 4 review again. So if you go to the bottom box in section 5.2 here, as we work our way through, this is also review. Okay, and so just I'm not going to spend a lot of time on this, but polynomial functions. We talked before, all they are linear functions are polynomial. So are quadratic. The other before break in 5.1, we talked about can't think of what I'm talking about. Cubic and quartic functions. What do those look like? What's the end behavior? Some of the features. Okay, so that's this chapter is all about polynomial functions. Okay, we talked about the degree. That's going to be a big factor in this whole chapter. Is what degree is this function, and what are all the different? What does that tell me? There's a lot of stuff that I'll tell you that the degree is going to talk about. We're going to add to that today in section 5.2. End behavior. If you remember, this is the one I think from 5.1. If I had to guess, this is probably the part that most people are struggling with, if you're struggling at all, is just still trying to either write it or just understand kind of what it is. So we'll focus more on that today. But basically, we're looking at the two ends of the graph. As x goes to negative infinity, that's the left side of the graph. As x goes to positive infinity, that's the right side of the graph. What's happening way in the past and way in the future. Okay, that's what we're looking at. And then last thing, this came up, I think, the other day. Yeah, Eddie asked me this the other day. You'd asked what zeros are. Here it is, a revisit again. And this will make more sense today. But x-intercepts, zeros, roots, those are all interchangeable terms that are used in different scenarios, but all mean the same thing. And like I said, I'll connect that up today. Okay? So This is not in your packet. This is something I added in, but let's kind of quickly review. This is in your the last packet, the 5-1 notes. Let's do a quick review here. 0 degree functions, what are they called? Not 0. I don't remember. This one would be the one you might not remember. These are called constant functions. Yeah. Okay. 0 degree are constant functions. What about 1st degree? They're linear. Those are all the lines we talked about. Okay. Linear. What's the next one? Quadratic. All the parabolas. Next one is cubic. That's what we've now started to add in. 4th one is quartic. And number 5 is quintic. Very good. Okay. So there's just the different types of functions based on the degree. And then if we add to that, kind of there's like your first name, if you will. This is more now like second name or last name, if you will. If there's only one term, meaning there's nothing added or subtracted to it, what's a one-term polynomial called? Monomial. Mono meaning one. Okay. That is a monomial. So you could have a linear monomial, 4x. That's an example of a linear monomial. First power, only one term. Okay. How about 2? That is a binomial, bi meaning 2. So again, I might have a quadratic binomial. 3x squared minus 5. Okay, you got it. Quadratic and 2 terms. And what's the next one, Eddie? That is a trinomial. Okay. What?
Like a tricycle.
Oh, there you go. Yeah, yes. Trinomial, 3 terms. Okay, and then anything that once you get to 4, there's just no specific name at all. No specific name. So you would say, I have a cubic function with 4 terms, cubic function with 6 terms, a quadratic function with 5 terms, okay, something like that. So there's no specific name. You just use the number of terms in that case. Okay. We had talked about that. This was one of the things we talked about back in section 5.1. The second thing then was about the general shapes of the different graphs that we're looking at. And I'm going to go a little less specific than I was in 5.1 because you already have these notes. We've already covered it. But lines generally look like one of 2 things. They're not. This isn't in your packet. I added this afterwards. Lines generally look like one of 2 things. They either increase if you have a positive slope or a positive a value, if you will, or they decrease. Okay. Quadratic, same thing. If you have a positive a value, they open up. If you have a negative a value, they open down. Okay. That's where we've been, and now here's where we're headed if we add to this. Cubic functions, 3rd degree. Anybody remember? What's a 3rd degree function look like? It's kind of that roller coaster, okay? And remember the other thing we talked about? The degree tells you the number of changes of directions in the graph, okay? So a 3rd degree function, if a is positive, starts down low, goes up high, back down, back up again. There's when you have a positive a value.
On some of them, like, I think actually, it was like on the pack or something, some of them like go up and then back down to where the arrow is.
Yep.
Is that like, okay?
Yeah, that's fine. So you might have, there might be just a little small loop. There might be a much bigger loop. There might be almost no loop, okay? And that all depends on some of the other features of the graph. But yeah, it could be just a little bit of a change of direction, might be a big change of direction, or it might have be almost no change of direction, but just real subtle, okay? That's if your a value is positive, just like a line, just like when you have a slope, it's generally increasing. Yeah, there's a little change of direction in the middle, but it's generally increasing as you work left to right. Same idea here. If a is negative, it's generally decreasing. Okay. And finally, how about a 4th degree? What are the 2 options? Yep. Just like a parabola, it either opens up or down. Okay. W. Here's your 4 changes of direction. Down is 1, back up is 2, back down is 3, back up is 4. Or if a is negative, opens the other way. Opens down instead of up. So there were 3 main ideas from section 5.1. One of them was, what are all these things called? Number 2 was, what do they look like? And then number 3 was the end behavior, which we'll talk about shortly. Okay, but that's where we're at. That's where we're looking at. Let me stop for a second. Anybody questions? Remembering this, coming back, hopefully? Okay. All right. Then let's add to it. Here's some things that now we're going back to the packet. This is back in there. So 2 more vocabulary terms that are kind of easier to see than define, and we're not going to spend too much time on them, but they're called relative maximums and relative minimums. Also known as turning points. Yeah. Yeah, go ahead. Also known as turning points. So if you remember on Monday, I told you before we had 3 forms of a quadratic. I said we've got vertex form, we've got standard form, we've got intercept form or factored form. And the 2 forms I told you to focus on were the intercept form and the standard form. Part of the reason, we have multiple vertices, if you will. We don't have a way to find them anymore. Until you get to calculus, there's no way to find these values unless you just graph it on a calculator or something, okay? Once you get into calculus, then they start talking about how you can actually find those values and how you can work your way through it. But until then, you don't have any options. So for now, all we're going to talk about is kind of what we're going to name them. Relative max, relative minimum, okay? So just like on a parabola, when a parabola is opening up, we've got a minimum value. When a parabola opens down, we've got a maximum value. What do you think this one is right here? Not number-wise, but I just mean like relative maximum or relative minimum? Minimum. It's a low point. That is a relative minimum. I'm just going to label it on the graph. That is a low point on the graph. Okay? How about the next point if we could work our way to the next one? Maximum. There's a relative maximum. That's a high point on the graph. Okay? So this is a relative maximum right here. And then we go a little bit further and we end up with another relative minimum. So we end up, that's why I said they're also called turning points, where it changes direction. You either have a minimum or a maximum, a relative min or a relative maximum on the graph. For now, in Algebra 2 and even most of pre-calc, you're going to go through and just kind of identify these and not really worry too much about trying to find them. That's why they were labeled here on the graph. Okay, so just another feature of some of these graphs that we're talking about. All right, let's keep going. On this one, let's go through and actually do some of the information here, okay? And then we'll add to it. So here's where we're going to revisit the concept of end behavior from 5.1. First question, by the way, and I think it's actually down here. I'm going to skip all the way down to the bottom. First question. What do you think the degree of this polynomial is? If you're just looking at the graph and you had to figure out the degree, what do you think? Ty, why do you say 3? Okay, yeah. Going up 1, back down 2, back up 3. And what I told you before, as we add to some things, there's multiple other reasons as well, okay? And that's where we're headed, is we're going to start looking into some of those other reasons. But in this case, you would say that this is a cubic function, and the general reason why, it's got the general shape, but then, like I said, there's some other things that will add to that as well.
Because it has 3 terms for that too.
When you say 3 terms. I think you said 3 terms. Yeah. There's three different ways to go. Okay. If you notice, by the way, how many turning points do I have? 2. Okay. How many? If I start doing relating some other stuff, how many turning points? How many maxes or mins does a line have? How many turning points does a line have? None, right? Doesn't turn at all. So first degree has no turning points. How about a second degree? 1. It's the vertex. It's either a maximum or minimum. Third degree has. Fourth degree has. There's always one less turning point than degree. So if you're going to say that this is a third degree, you could also say, well, it's only got two relative max or min. There's 2 turning points. There's another reason. Okay, and like I said, we could keep adding. There's about 3 or 4 other reasons that we could add in. Let's take a look at end behavior. And like I said, this is probably the one thing that most people have said so far that they're struggling with. So let me work our way through this one. as x goes to negative infinity. So the different way that I'm going to describe this today that seems to be connecting with students a little bit better, as x goes to negative infinity really says, as I go to the left, where does y go? Up or down? Down.
So it's negative?
Meaning negative infinity. All this says, the end behavior says, as you go to the left, y is decreasing. It's going down.
You go left, y goes down.
Yeah, left, down. That's all it's saying. Okay. If I do the same thing as x goes to positive infinity, now we're saying, as we go to the right, where does the graph go?
Down and up.
No,
Down.
all the way to the right.
Oh,
We're going up. As x goes to positive infinity, the graph is going up to positive infinity. That's all there's your end behavior right there. You're describing what's happening on the two ends of the graph. As x goes to the left, gets really, really small, graph goes down. As x gets really, really big, graph goes up. And remember, the point of this, by the way, you might just say, well, who cares about the ends of the graph? But if you think of it in a context, everything we do is in that context of predictions and coming up with application problems and those types of things. That end is we're predicting the future. That end is we're predicting the past. Okay? That's where end behavior is. It's basically a future and a past prediction. What was going on? Roots in this case. Remember, roots, x-intercepts, zeros, those are all the same thing. You look at the graph, what are my zeros? I've got 3 of them. What are they?
0, 1, 0. Negative 1, 0.
Yep. We got it. Negative 1, 0, positive 1, 0, and positive 3, 0. Okay? So my roots are negative 1, positive 1, and positive 3. Okay? Those are the 3 roots in this case, or zeros. Which,
So basically it's your axis.
what's that?
Basically it's your axis.
Yeah, the x-axis. Yep. You can, I mean, don't get me wrong. You could write them as a point. If you wrote it as negative 1, 0, positive 1, 0, that's perfectly fine too. And then we talked about the turning points. All I want you to do for now is just be able to label it. What would I label this point as? Relative maximum or minimum? Yeah, it's a high point. So this is a relative maximum. And next one would be a relative minimum. It's a low point in the graph. By the way, just a quick heads up so you understand why we're not just calling them maximums and minimums. The word relative, is that the highest point on the graph? That's why it's called relative. It is a high point. It's not the high point. Okay? That's also why when we did parabolas, why we didn't use the term relative max or relative minimum. Because it was either the high point or the low point. So that's why they're called relative maxes and mins. Okay? All right. Let's keep going. Now we're going to start to put some things together. I'm going to skip this slide. We'll come back to it if we need to. Here we go. Now we're going to start to combine some degree. Go to the table on this one. So if we have a line, what degree are lines? 1. And what's the maximum number of zeros that I have for a line? How many x-intercepts? 1. You're going to go through a line. We'll only cross the x-axis one time. Okay? So maximum number of zeros is 1. How about a parabola? What degree? 2. That's quadratic. Maximum number of zeros. How many times could it cross the x-axis?
2.
Yeah. Could it be less than 2, by the way?
Yeah.
Yeah, you could have less than 2, but maximum is 2. Cubic. What's the degree? 3.
Can it go over 3 times?
You tell me. That's a good question.
Well, if we go
3. If this is your x-axis, could come up, cross, back down, cross, back up, cross again. So 3. Let's go one more. What we've been talking about.
4.
4th degree, maximum. With the W or the M, how many times maximum? 4, right? If it's an M, cross, back down, cross again, back up, cross again. Okay, so it could cross 4 different times. Which means now, this is kind of in general. What's the pattern? Yeah. The degree also tells you the maximum number of zeros that you have in any given. So when this says a polynomial of the form x to the n, I have n degree, which means I have n number of zeros. If I had a 10th degree polynomial, I have 10 total zeros. Okay? If I had a 4th degree, I have 4 total zeros. So there's another thing that the degree tells you. It will tell you the maximum number of zeros, which also, by the way, is what's called the fundamental theorem of algebra. The degree of a polynomial is always equal to the number of roots or zeros that you have. Now, one thing I will tell you, and we haven't done a lot with this yet, but we will as we move forward, roots or zeros could be real or imaginary. And we'll talk about that in just a little bit as well. And sometimes you might have multiple real roots or multiple imaginary roots. Okay, we'll get into that. Let's go down here for a second then. Let's go down to just a couple of quick examples. How many roots would I have here in problem number 1? Total. Yeah. Cubic function, 3 zeros. Okay. So that one's 3. How about the next one? 1. The line, x to the first power is x. Therefore, you know you have 1 total 0. How about number 3? 6. 6 degree function, therefore 6 total zeros. Okay, 6 total zeros. So far, how are we doing? Starting to see, the biggest thing is trying to make the connections. What's that, Eddie? Yeah. Because the degree is 6. Whatever the degree is tells you how many total zeros you have, or how many total roots that you have. Okay? All right, let's start putting this together now. So here's the next part. So if we start talking about, and we'll talk now why they're sometimes called roots rather than zeros and x-intercepts. Okay, this is where we'll introduce that idea. So notice, here's your 4th degree function right there. There's the graph of it, or at least part of the graph. We didn't zoom out to see the whole thing, but there's part of the graph right there. So first thing, let me write this down. Zeros. First zero. Got an x-intercept at -4. Second zero. Another one at -2. Third zero. Another one at -1. Last zero is over there at +2. So notice, 4th degree or zeros, kind of like what we were just talking about. Now, here's the connection. Okay? If I want to go from a 0 to a factor, and this is why I told you the other day to start focusing on factored intercept form. Okay? There's your intercepts. We're going to now rewrite this. So if that is a 0, that means there's my x-intercept right there. Let's work backwards. If I wanted to get this equal to 0, I could take that -4 and just add it to the other side. And now I've got x plus 4 equals 0. There's your first factor right there. Okay? You have no idea how to factor this right now. Okay? None whatsoever. We have not talked about it. It's a really complicated way of going about things. But you know that if this is a 0, think back to the 0 product property. If one of my factors was x plus 4, that means -4 was my 0. I'm just working in reverse. Okay? So, hold that thought. So factor number 1 is x plus 4. If I move to the next one, -2, that means x equals -2 is a 0. But if I want to work backwards and write it as a factor, I do x plus 2 now equals 0. There's my second factor, x plus 2. Okay. Well, now I'm going to skip straight to it. What would the next one be? X plus 1 would be your next factor, and your final factor would be x minus 2. Yep. Now, here's what I want you to connect. Let's say you took this and you multiply. Let's say you FOIL this out completely. You got it. You get that. Okay? So what I want you to recognize here and what I want you to realize is you can go from zeros to factors to the equation. Okay? Zeros, factors, equation are all connected to each other. So I told you this would also be the reason why right here we would talk about why they're called roots. Think about just growing a plant or something, or vegetables or whatever. Start with the roots and it grows up. Here I'm starting with the roots, went to the factors and ended up getting the equation. That's why they're called roots. It's where we started the problem and then it grows from there. Okay, so that's another way of looking at things. All right, let's keep going. And then we'll put it all together here. So there is a thing called multiplicity of roots, okay, that you have to be aware of. This is what you know most of the time, right here. This is everything we've done so far. We have not talked about anything other than this. And what I want you to notice, so notice -3 is one of the zeros. X plus 3, therefore, is a factor. +1 is one of the zeros. X minus 1 is one of the factors. And finally, 2 and x minus 2, so it's like what we were just talking about. Okay, yeah, Eddie?
And that's like when you get that answer and then you flip it, right, x equals like +2.
Yeah. Yep, that's exactly right. So the reason why these are single roots, okay, is because they go through the x-axis. Goes through at -3, comes back through at +1, and then goes back through at +2. But now if you take a look at the next one, when we start talking about what are called double roots, what do you notice? If you looked at the graph, what would you say, how many zeros or x-intercepts are there? You'd look like you'd say there's 2, right?
But there's not.
But there's not. It's actually 3. It looks like there's only 2 spots, but there's actually 3 here. One that goes through, but anytime the graph comes down and touches the x-axis, that's what's known as the double root. There are actually 2 of them at that point. Okay, so yeah, it's only one number, but there's 2 factors to still turn this into a cubic function. Okay, and these, by the way, are the 2 main ones that you need to know. If it goes through the x-axis, it's a single root. If it touches the x-axis, it's a double root. There's two zeros in that spot. And then the last option, which we'll talk about a little bit, but not really use too much, is you could also have a triple root. And this is kind of Ty, when you were asking before about like the different shapes of the graph. This is still a cubic function, even though there's not really a up and then back down. It kind of just flattens out. Well, if it flattens out at the x-axis, that's what's called a triple root. So it looks like there's only one there. There's actually 3 of those. Okay. But what I want you to mainly know is this right here. Single and double. Those are the main ones. Single go through the x-axis. Double is when it touches the x-axis. All right, let's put it all together here. So how do we go through and how do we see imaginary roots? How do we put all this stuff together? So first thing we're going to write down, total number of zeros. How many total zeros do I have for this problem?
2.
Think back to the fundamental theorem of algebra that we said earlier.
4.
4. Why 4?
So there's 4.
Fourth degree. There's got to be 4 zeros total. Okay. And now where we're headed is how many of these zeros are real zeros versus imaginary zeros, things like that. So if we take a look, how many of these are real zeros? If you look at the graph, how many zeros do I have on the graph? Where's it, Matt? Yeah, we got 2. One there, because it goes through the graph, and one there, because it goes through the graph. So I've only got 2 real zeros. Real zeros you can see on a graph, which means by default, the other 2 have to be imaginary. Later in the chapter, we'll talk about how we find all of them, whether they're real or imaginary. For now, it's just identifying how many you have. Okay? As we move forward, we'll figure that out. But for now, it's just an identification. 4 total because it's 4th degree. 2 real because that's what's on the graph. And whatever's left over has to be imaginary. All right, this part I'm going to actually skip this slide because we've kind of already talked about it. And we saw this is the exact same slide from the last lesson. End behavior. We had said even degrees start and end in the same spot like a parabola or a W. Both going either to infinity or both going to negative infinity. Okay, both pointing up, both pointing down. Odd degrees kind of act like lines where you're generally increasing, even if there's a little, change of direction in the middle, or generally decreasing. So this one we've already kind of talked about, so I'm going to skip through that. And here's where we wrap it all up. We got a couple of examples here for you. So I want to make some connections between graphs and equations. If I was going to write, if this is all you're given, and I wanted to write the equation of this graph in standard form, we're gonna work our way through the process we kind of just talked about.
Right.
It is, but we're gonna get there. We're gonna see how you get from here to there. So first question I have for you. How many real zeros do I have on this problem? 1, 2, 3. Okay, and it should match up as well that this is, granted, you can't see the whole picture, right? But generally, it looks like it's probably a cubic function. Okay, so if -4 is your first zero, what's your first factor? X plus 4. I'm going to put down here y equals x plus 4 is my first factor. What's my second factor? X plus 3. What's my third factor? X minus 6. So I went from zeros to factors, and now we're going to go from factors, and I'm going to create a little extra space here for myself. So the question is, how do I get from here to there? Eddie?
You gotta multiply them all.
Yeah.
To get to the first one, and then, wait, how would you get to the? I feel like I got everything but the second one.
And so I'm going to give myself a little bit of space here on this one. We'll do this one together. This, by the way, is something you will need to know how to do. It's not by any means right now the most important thing, okay? But I want you at least to be able to see it and be able to work your way through it. Here's how you multiply these things out. Take two at a time. I'm going to go with these two, okay? And it doesn't matter whether you choose the last two, the first and the last one, does not matter the order. Okay? So I'm going to take the x and distribute. So we get y equals, I'm going to put this in the answer in parentheses, x plus 3x. Then I move over, distribute the 4. We get 4x and 12.
Wait, do you just do that 3 times, each of them, and then add all those?
Hold that thought. You have the right idea, though. You're on the right track. I'm going to leave that x minus 6 there for a second. And I'm just going to clean this up. I don't have to clean it up right now, but I'm going to just to make the next step a little easier. I've got a 3x and a 4x. I can put those together. So we've got y equals x squared plus 7x plus 12 times the x minus 6. All right. Now, I'm going to take the x minus 6 and distribute it. And I think this is what you were saying, Eddie.
Oh.
If I take the x, I'm going to distribute it to all 3 parts. X times x squared gives you x cubed. X times 7x gives you 7x squared. X times 12 gives you 12x. And now we move over and distribute the -6 to all 3.
Yeah, where you do that.
That's what you were saying, right? I think.
Well, no, I was thinking, I thought that you do that, so you know how you got your first one?
Yep.
And you distributed those two?
Yeah.
I thought you do like, say like, the one like you did, and then x plus 4 times, x minus 6, and then.
Oh, okay.
X plus 3 times, so you.
Yeah, I got you. You were going to do like one at a time. Yeah, no, you want to get an answer and then take that answer times the next factor. Okay? And we'll talk about even if we even had to go further than that. So -6 times x squared is -6x squared. Times +7, we get a -42x. And times 12, we get a -72. And now, if we clean this all up, there's your answer. That's where that answer is coming from. X cubed. 7x squared minus 6x squared gives you a +1. 12x and a -42, there's your -30, and there's your -72.
What happens if you don't have any, if you don't start with any zeros?
You'd have to. You'd have to go through it. And that's kind of what we're doing right now. That's the whole point. That would definitely be messier.
That will screw me over.
We'll get to that. Don't worry about it right now. No, that will not be on. Like not with a decimal or anything.
Good.
This type of stuff, speaking of tests, I'm glad you brought that back up.
You're welcome.
As you go through and you take a look, so like I said, it's chapter 4 review, and then it's only the 5.1 and 5.2 stuff, okay? So for example, 5.1, like I said, it was what's the general shape and end behavior of the graphs, and now 5.2, we're talking about all this idea of zeros and roots and equations and stuff, okay? This will be the only stuff you see on chapter 5, or from chapter 5, excuse me.
That's it.
That's it.
Easy.
Last one.
Maybe not.
And this one I'm not gonna spend too much time on, because it's pretty straightforward.
This is the same thing.
Same idea, there's one little difference, and I'm not gonna multiply this one all out.
Is it because of that being negative?
So first question, how many zeros right here?
4, 3. 4.
How many zeros at that point?
1.
One, because it goes through the x-axis. So therefore, at -4, I can write down x plus 4. There's my first factor. How many zeros here?
X plus 3.
2. There's 2 of them. That's that because it touches the x-axis. So there's actually 2 factors there. 2 of these x plus 3s.
And then X minus 6.
And then the last one is x minus 6. Once again, there's only 1 because it goes through there. And this one I'm not going to multiply out. But if you did, again, you'd take probably the first 2 and FOIL it, second 2 and FOIL it, and then multiply those 2 answers together. It gets kind of messy and long, which is why I'm not going to do it. But ultimately, that's where this answer would come from.
So you could end up potentially with like, so the more zeros you have.
Yep.
The bigger.
Yes.
What's that one called again?
Yep.
What's that number called?
Did you agree? Did you agree? Factors?
The square numbers will get, right?
Yeah.
Degree.
Did you agree?
Yeah.
Fourth degree.
That's what I mean.
4 factors, 4 zeros. Yeah. Yes. So the more zeros, the more factors. And that's one of the main ideas we're trying to get at is connecting that the degree tells you a whole lot about the graph.
Is that also how you can check if like if you're someone right? Because if you got 4 of those, if you start with 4 of those, you should have 4 degrees.
Exactly. Yep.
Oh.
Yes. Hey, you're making connections. It's all coming together. All right. Here's what I have for you. So, with the rest of the day, you got about 15 minutes left still. Okay? With the rest of today, if you have not completed the 5-1 worksheet yet, and that was the one I gave you before break, remember it was a packet? Go through and work on that, and that way I can come around and help you if you're stuck on anything. Submit that, get some credit for that. The second worksheet then was attached. I had told you not to worry about that. Don't do it yet. Well, now that's your assignment. That's what I want you working on in the next 15 minutes. That way, if you do have a question about something, you can let me know what you're looking for. Okay? Other than that, I'm going to get out of your way. I'm going to let you do some work, and I will check in with you to see if you need anything today, or like I said, come on in on Friday if you need it. All right. Who are you doing okay?
Yeah, doing okay.
All right. That is all I've got for today.
Okay.